Hey folks, welcome out there to TNLearn Mathline Summer School. I'm Ernie Roberts. I'm your host for TNLearn Mathline Summer School. Today's session, hey, we have had fun all summer. The summer's getting closer and closer to coming to an end. We will be back live on August the 8th, just to let you know. Put that on your calendars. But until then, all our shows are going to be pretty much spectacular, special, and they're to help you get ready for that next grade school year coming your way, all right? Some of these will be algebra, some of them have been basic skills, some of them have been kind of a mix. And you know what? Let's see what today is going to be all about. Let's see what we got coming. I see random days and Mondays. This is a Monday, but you know what? It's the start of a great new week, and random days simply means we've got a few problems here that really don't necessarily follow any theme today. We've picked up a few that have been left over from shows in the past, and we're just bringing them together because we didn't get to them, all right? So let's have some fun, lay back, get some math, get a pencil, paper, and maybe even a calculator might be needed, but let's get ready to do some good math. What's our first problem, randomly speaking, today? Looks like an evaluation problem where we get to substitute. And if you'll notice, we got a negative number in there, -3 for x. We have a 5/6, the fraction involved for y, and another fraction out there involved with z, all right? So let's rewrite this formula while y'all are at home doing that too. I'm going to do the same thing here. And we got xy, that is a y, minus, let's make that y look a little bit better. Y here, that's better, minus z. And what we're going to do, we've got this simple situation here that we're multiplying. This says we're going to multiply. This says we're going to multiply. Remember, our order of operations say we multiply, then we'll play with the subtraction business, all right? So let's see what this is giving to us, all right? First thing we're going to do is substitute. We're going to substitute. So I'm going to put a -3 right in there for the x. I'm going to multiply it by 5/6, because that's what it says. Let's multiply x and y. And you know what? Just to make life easier, I'm going to put a 1 right under that 3, all right? That's going to make life easier for us. Let's close that parenthesis, and we'll have to do that first, all right? But we'll deal with that in a minute. We're going to also subtract. Let's finish our substitution here. Let's put a 5/6 in for y, and we're going to multiply that times a 1/5. Okay, there we go. So this looks kind of crazy, doesn't it? Because some of you are like, ooh, too many fractions for my taste. Well, let's see what's going to happen. We're going to get rid of a few of them. Let's take a look at what happens with a -3 times 5/6. Folks, we can do a little cancellation on the diagonal. Right there we go. How about it? We'll cancel 3 into 3. It goes one time. By the way, keep that negative there. Don't lose the negative. It didn't go away. And down here, we're going to have a 2, because that's how many times 3 will divide into 6. It goes 2 times. So I'm seeing, very important, keep that negative, like I said, -5/2. What's going on in our next fraction? I see cancellation. I see cancellation. You see cancellation? Let's do it. These 5s take care of themselves, becoming 1s. Now be very careful. That 6 is not in the numerator. It is in the denominator. All right, so we're going to end up with -1/6. Now you look at that and say, ooh, Ernie, we do not like negative fractions. Well, we don't like fractions in general for most of you out there. But let's play with this, because it's not that bad. It's not that bad. Common denominator time, because we are doing a subtraction, all right? So let's make that common denominator. I notice that 2 will go into 6 evenly. So you know what? That is going to give us a 6 in both cases. And we're going to keep that minus rolling there, all right? By the way, go ahead and put a 1 in there. It didn't change, all right? What we got to worry about is what's happening here, all right? So we're going to say 2 goes into 6, what, about 3 times? And 3 times that -5 gives me a -15. Now, folks, this is just like saying plus a negative, all right? Just like saying plus a negative when we subtract that. So sometimes we get really nervous. What do we do with the signs? What do we do with the numbers? But all we've got to do is add these two numerators together. I believe it's going to give us a negative, look at that, 16, because the signs are the same. We add them together, keep the sign, over 6. Reduce, simplify, however you want to do that. Let's call it what it is. Mixed number time, all right? Certainly one thing we can get is a -8/3, all right? That's one option, dividing both by 2. And you know what that gives us is a mixed number, 2 2/3. There is your negative form. By the way, the final answer is a negative. It is a negative there. All right, y'all good with that one, I hope. All right, everybody got that right out there? Check, check, check. All right, let's move on to our next next situation here. It says it's going to be random today, so who knows what's going to pop up next. Let's see what we've got, folks. We've got a little equation. It says solve and check. And we are going to do just that. It says negative 12x. Go ahead and write that down at home. Plus 48 equals to 16 minus 4x. All right, we've got x's on both sides. Would be nice to get that x to the left or x to the right. I'm going to take it to the left. I'm going to take it to the left, all right? So in order to do that, we've got a minus 4x hanging out here. We're going to add 4x. Y'all got it over there? And if you add it to the right-hand side, you must do it on the left-hand side. So let's do it. 4x, right there we go. Let's see. The whole reason was to make them go away, and it just did. Over here we get a negative 8x. Notice that negative 12 is going to win out over the positive. All right, and it's going to be a negative 8x. We've still got plus 48 hanging on for fun. And on the right-hand side, we've got this 16 that looks pretty happy also. And also, we've got an easier-looking equation. You see, we're simplifying at this point. We simplify, and then we're going to just do a quick operation and finish it off, okay, once we're done. Let's see. This plus 48 would be nice to join up with the 18, or the 16 over there, actually. Don't do this, folks. Don't add 48 and 16. You've got to move it across the equal mark, okay? It's kind of moving across enemy lines here, all right? So we're going to subtract our 48. Got to do the subtract. And we're also going to subtract 48 over here. Now, watching signs, you know the answer is going to be negative, all right? And let's see. 48 minus 16, that's what we're worrying about. It's going to give us 32. And it's a negative 32 because that negative is winning the battle here. And say goodbye to this guy here, and I see negative 8x coming down. Divide both sides by negative 8. I'm going to take care of it. I bet many of y'all already finished the problem. All right, let's just see what we get here. X will equal 4. And my question is, does that check? Does that check? This is a very unique situation. I'm already looking at the 4 going in right up here. And I multiply. Remember, we multiply first. We don't say 16 minus 6 and then multiply by 4. We multiply the 4 and 4 first. That looks like 16 minus 16, which tells me 0. Let's see what happens on the left-hand side. I've got a 4 going in over there. Got a 4. And I've got negative 12 times 4, which gives me negative 48. And that's 48. Also, I get 0. So, my friends, it does check. That's what we do. Remember, we multiply first, then we add the 48. Over here, we multiply the 4 first and then subtract it from 16. In both cases, we ended up with 0, 0, 0. All right. So, hope you all got the same answer out there. If not, hey, try it again. Try it again. You wrote it down. You can do it again. Let's check our next problem out here. Let's see what's happening here on this one. It says 5 times the parenthesis. Whew, write this one down. It's a long one. 3 minus a inside the parentheses. We're going to distribute. Remember, we don't just say 5 times 3 and forget about the a. We got to go all the way through. On the other side, we've got some other stuff going on. We've got a 4a minus 9a, and we're adding 12. All right, so what we want to do, we're looking for, by the way, the whole point of solving and checking is we look for a solution. We look for something that will make both sides equal at the same time. All right. They balance each other out. So let's see what's happening. On the left-hand side, I am distributing, just like I said we would. And we've got 15 minus 5a. All right, that looks good. On the right-hand side, we got 4a minus 9a, which is going to be also, well, it's going to be negative 5a. Okay? 4 minus 9 keeps me a negative 5. Bring the a along for the ride. And I've got this plus 12 hanging on out here. All right? Now, typically what we like to do, we like to move the a's to get them all together, either on the right side or left side. So let's just do that. We've got a minus 5a here. We're going to add 5a. And make sure that you are adding 5a because we want this to go to 0. So all we're going to have left is a 12. All right? Now, let's see what happens on the left-hand side. Woo! Something strange is happening on the left-hand side. Well, not necessarily strange, but it is happening. These are going away too. So all I've got left is the number 15 equals 12. Absolutely not true. This is false. You say, well, Ernie, what does that mean? That means no matter what number I put in for A over here, I'm going to always be 3 larger on the left than on the right. Because I could also go ahead and say subtract 12 or subtract 15. But it's still not going to work out. This is not true. It's false. So you say, well, what's the deal? What's the solution? Absolutely no solution. All right? No solution, all right, to this problem. I don't care what number you throw in there, it's not going to ever equal out. It's not going to equal. The left side and the right side will not equal. So that happened because the A's disappeared. Now let me caution you, sometimes my students think, oh, maybe I had 10A over here for some reason equaling 0. Is that no solution? No, 0 can be a solution, but this is not a 0 solution because I put a 0 in here, I have just as much a problem as if I don't. All right, if I have 0, I get 15 and 12. All right, so that's not going to work. It's not going to work. So absolutely, in this situation, when the variables disappear, if it's false, there's no solution going on there. All right, no solution on that. So that only time we say no solution, it's not when it's difficult, when we can't figure out an answer. It's when the variables disappear, then there is no solution that's going to make this work. All right, at least as long as those two numbers that are left are different. Okay, now let's take a look at this next one here. Let's take a look at the next one here. Distributed property, we seem to love that stuff, don't we? So we're going to multiply, we're going to take it, and we're going to get 8x minus 20. I'll go ahead and write this one down at home, all right? Got 4 times parentheses, 2x minus 5. And on the right-hand side, we got some things to combine, like 4x plus 4x minus 20. And on that side, let's go ahead and do that while we're at it. Let's go ahead and add 4x to 4x. We get 8x. And we have, minus 20. Now, some of you already noticed something here. This looks like, you remember the geometry and algebra problems? They call this property when something is equal to itself. We say, well, isn't that an identity? Yep, it is an identity situation. And the property is what we call the reflexive property, when an expression is simply equal exactly to itself, no switching numbers around, no moving things, whatever. In this case, this is A equals A, so to speak. It's an identity. Now, you say, well, Ernie, what if we didn't notice that? Yeah, what if we didn't notice? So let's go ahead and get rid of it, see what happens with our x's, and I'll show you why we call it an identity. We subtract 8x from the right. We're going to also subtract it from the left. Good old subtraction property, equality. This is an equation. So here we go. We got negative 20 and we get negative 20. Well, folks, this time we have a true, because that is true. Negative 20 is equal to negative 20. So, well, what does that mean? That means no matter what number I pick for x, it's going to work. So in this case, the solution will be all real numbers. So it's kind of like that statement, it's either all or nothing. When the variable disappears, it's either going to be everything's going to work or nothing is going to work. All right? Those are the storylines here on this. So if it's a true statement, you're good. Every answer is going to work as long as it's an equality. And if it's equals and you don't have two numbers that, remember that was the problem before, no solution. So I said all or nothing. This one was all. This one was all. So now you've seen a little bit of the chances that things can be quirky. So basically there's either going to be one answer, no answers, or everything works. That's the situation. So let's take a look at an application here. It says Elsa works 10 hours a week part-time. She also earns a $20 tip. All right, so that's not per hour. She just got that as a little extra. So she earned a total of $92. What was her part-time hourly rate? Well, let's see what she's done here. First of all, we need to define a variable. That's the first thing. Whenever we do these great things, we're going to call this H. Why not? H equals the number of hours that Elsa worked. All right, so we want to explain what we're using here. We know that she gets paid a certain amount. All right, actually H is just hourly rate. All right, let's call that hourly rate. We already know how many hours she worked, didn't she? She worked 10, so we want to know how much did she earn. So this is an hour's rate. All right, it will be H. So let's see, we've got 10 times that hourly rate, and then she earned a $20 tip in addition. And her total paycheck for that month was $92. $92, all right? Or for this week, actually, it says, right? For a week, 10 hours in 1 week she worked. So let's see. Yeah, 10 hours a month isn't much time to get going. You're just barely doing anything. But 10 hours a week, not bad. Not bad here. Let's see what Elsa is going to make. Now, we've got to remove this 20 in order to figure out what the hourly rate is. So we're going to subtract that 20. Going to subtract that 20 on both sides. See, there it goes. We got 10h. You got 10h, I hope. I got 72 over here. That's what happens when we subtract that 22. Now, some of you are going like, oh, Ernie, 10 doesn't divide evenly into 72. That's all right. What happens? We're talking about money here, all right? We're talking about money. This is $92. We've taken away 20. Now we've got $72. We can make things happen with nickels, dimes, quarters, all those good things. A change, all right? So let's see. We're going to divide both sides by our 10. And you know the easy secret trick to this, folks, is simply move that decimal in one place, because we're going to divide by a power of 10. All right, so the 10s go away, and this is going to give us $7.20. That's what she makes per hour. That would be per hour. That's her rate. Okay? Quick check. You say, well, Ernie, how do we know that's a good answer? Well, because we found it, one thing, no, but because we do want to check. We do want to check. So take that 720 times 10. That gives you $72. Add on the 20, you're back at 92. And I bet some of you said, you know, I think I could have figured that out in my head. You probably could. You probably can. But again, there's always the good old algebra approach. There it is. And there's your check. All right? And it does work. It does work. Good paycheck there, $92. Not bad per week. When you start multiplying up that by 52, Elsa, not bad. Did some good work. Did some good work there. All right, let's shift gears here. This one really, talk about a random day and a Monday problem here. Woo! We're going to FOIL, and there's all sorts of square roots popping up here. Some of you said, whoa, boy, how did this get such a different swing all of a sudden? Well, let's see what's going to happen. The FOIL, remember FOIL, it means first, outer, inner, last. This comes back to our weeks and weeks of radical study that we did earlier in this session. Now, let's see what's going to happen here. We're going to take our first, and I'm going to write them down because these are rather nasty to think and remember in your head. All right, so let's do it. Square root of 5 times that square root of 14. Woohoo! All right, that's the first. Yeah, I didn't say it was going to be easy. This was a random problem today for sure. Let's pull out here. Whoo, babies. Let's see. I have still positive, and that minus will come into play in just a minute. All right. So we got a square root of 5, put a parenthesis around just for the fun of it, and a 35 here, square root of 35. They're going to get multiplied together. Whew, boy, already I'm thinking this looks kind of nasty. Go to the inner. That's not so bad, but it's a minus. So it's a minus the square root of 2 times square root of 14. And I'm about to lose me over here. Y'all may want to just take me out of the picture. Let's see what happens. And we're going to say minus the square root of 2 times that square root of 35. Sorry about that. Well, maybe y'all are feeling a lot better. You just lost me out of the picture. Let's see what this is going to do. All right. First of all, right here, multiplying together. Remember, when the numbers are both under the radical, we just simply multiply them together. This is going to give me a nice old square root of 70. Some of you say, that doesn't sound so nice to me. Yeah. Well, let's see if it gets worse here. When we take 5 times, 135. Yikes, folks. Guess what that's going to give us? 175? 175, yeah. Y'all got it out there? Is that right? Oh, you can't call in and tell me, can you? We're going to go with it. This is 175. It is 175. Now, our next little piece over here, we got minus the root of 28. That's nice. And then we've got minus the square root of 70. Now, all these are square roots. All these are square roots, all right? The good news, there is good news here. Notice these square roots of 70, you can say goodbye to them. They cancel out. Now, what's going on in the middle? What's going on in the middle? I recognize 175. You say, what? Yes, I do. It's 7 quarters. So we can write this as 25 times 7. Some of you are doing that in your head right now, okay? And over here, we can break 28 down. That's really easy. 4 times 7. Now remember what I'm doing. I want perfect squares. And notice they're times the same radical. By the way, these are gone, so we don't worry about what the square root of 7 does for any of us. It's gone. It disappeared. That was the good news. That was the good news. All right, let's finish this thing off. We got 5 times the square root of 7. Remember, you take the square root of 25, bring it out. That's a 5. There's the root of 7. We're going to subtract. Perfect square of 4 is, well, the square root is 2. And we're going to bring it out. And we're going to leave that square root of 7 behind. And my final answer, and hopefully your final answer at home, is 3 times the square root of 7. Woo! And you could do that checking. The good news is so many things canceled out. We probably did the right things. But the biggest worry we might have is just make sure you did all your computations. You got the square root times 14 here in the 5. That goes together. That made 70. Back to 5 and 35. That gave us 175. All right. That was a big square root moment. Now we went to the inner terms, which were root of 2 and the root of 14. They were both square roots, so they make a square root of 28. And on the tail end, the square root of 2 times the square root of 35, well, that came back to another square root of 70. We watched our signs. They look good, all right? So there you go. A random problem for sure. Very random, but hey, it's a random day and a Monday here on Mathline. All right, let's take a look at our next problem here coming up. This is one that did not make the grade when we were doing some word problems earlier in the summer. How about it? 3 sides of a triangle are consecutive odd integers with a perimeter of 51 feet. What are the 3 lengths? All right, so we're thinking, first of all, we've got to understand there are three lengths, all right? 3 sides here working. And the big deal is they're consecutive odd integers. Now, odd means it isn't even, right? Yeah. So it's sort of like 1, 3, 5, 7, 9. Those should be the digits on the end of your lengths. And 51, well, it's an odd number. Maybe that has to do with something here. But that's what's going to happen is I want you to notice when I said 1, 3, 5, those are 2 units apart each time. 1, 3, and then 5. 2 each time. All right, so let's see. I'm going to let n be my natural missing link here. That's going to be my smallest, okay? My next one is going to be n plus 2. And you say, well, Ernie, I thought odd had to do with 1, 3, 5. Well, if I put 1 in for n, guess what? If I put 1 plus 2, I'm going to get 3. So this tells me that I've got to move 2 places, all right? It could be odd, it could be even to move by 2 each time. But what's going to happen is this number here is going to take care of us in the final answer. Hang with me. And as I always say, trust me. All right, so let's see. We've got n plus 4 right there. All right, so those are our 3 sides. 1, 2, 3. I can count. You can too, right? So here we go. We start here. That's our first. Here's our second. And how about it? We'll let that be our third side, all right? But what we want to do is we're going to figure out what n is, then we can add 2 and add 4, and we'll make sure they add up to 51 just for you all, okay? So let's do this. Let's make an equation. N plus perimeter. By the way, what does perimeter mean? It's not area, is it? No. It's simply adding all 3 sides. So here we go. We're going to take n plus 2 plus n plus 4. Now, I know some of you are saying, well, Ernie, could we just play with those in our head for a while? Well, you probably could. It may take you a while to find these 3 numbers. This is going to be a lot quicker. It's going to be a lot quicker, I think. So we get 51, and now I start noticing some things come together. I've got 1, 2, 3 n's here, and that will give me 3 of them. 3n, all right? I have a 2 and a 4. Everybody can do that in their head, right? Plus 6. And that equals to, y'all got it out there? 51. Yeah, it didn't change, did it? Now, let's take care of this 6. We're going to subtract off 6 first. And I see 3n coming out by itself. Over here, I've got 45. And divide by 3. Divide by 3. And I have, folks, I have n equals 45. No, don't have n equals 45. What's 45 divided by 3? Everybody hit those calculators. Hit those calculators if you need to. 15, yeah, there we go. That's a mistake that can be easily made. You get so excited you're there, you see 45, you forget about it. Of course, when you checked it, it wouldn't have made any sense, all right? So let's put it in here. We got n is 15. Remember, I said we're going to add 2 more, so here comes 17. Notice, hey, 17's odd. 15 is odd. How about it? Next one will be 19. It's odd. Let's add them together and let's see if we get. What number are we going to get, everybody out there? 51. Yeah, 51. Let's see if we get it. I've got 5 and 7. That gives me 12. Add a 9 to that. How about it? It's 21. Put a 2 up there. Carry it away. 51 total. And folks, these would be feet. All right? All feet, all feet, all three of them in feet. How about it, folks? How about it? It's a little bit of Random Monday. And how about it? Take a like and do that with us on Facebook, all right? www.facebook.com/TNLearn. We love to hear from you. Paste your compliments. Say if you like this show even today. Mathline at TNLearn.org. You can always take your email. We'll get your questions and your comments there also. And hey, YouTube? This show probably will pop up there before you know it, all right? www.youtube.com/TNLearn. If you'd like to repeat that, feel free to go down and download it and see it again, all right? Hey, thanks for being with us this afternoon. Summer School Mathline will be continuing throughout this week and through the rest of the summer. But you know, August 8th is soon, and we will see you then.